Good morning, everyone, and thank you for joining us. My name is Chelsea, and I will be your webinar producer today. And if this is your first webinar with us, then welcome. Here at CodeSignal, we're passionate about discovering and developing the skills that will shape the future. And as AI continues to reshape industries, understanding its trends and impacts is crucial to developing the skills needed to thrive in this evolving landscape. So today we are super excited to bring you a webinar on the AI revolution in tech, trends and impacts, where we will delve into the transformative role of AI in the tech industry with insights from a leading expert in the space, Cassie Kozrykov. Without further ado, I'm going to go ahead and pass it over to Brenna Lenore, our SVP of Marketing here at CodeSignal. Brenna, I'll let you take it away.
Hi, everyone. We're so excited to have you join us today. I am even more excited to be joined by Cassie, and I want to give just a brief introduction. I know a lot of you are already familiar with her and her work, but Cassie is Google's former chief decision scientist and an in-demand AI advisor working with leaders at places like Lenovo, NASA, and Gucci. That is quite a spectrum of different types of companies. In her almost 10 years at Google, she trained over 20,000 Googlers in data-driven decision-making and AI, helped over 500 projects implement data decision intelligence best practices. She's originally from South Africa, where she began her studies in statistics at 15. That is not what I was doing at 15 at the Nelson Mandela University. She moved to the US and completed her degree in economics at the University of Chicago. She's also earned graduate's degrees in mathematics, statistics, psychology, and neurosciences at Duke and at NCSU. Cassie is a top keynote speaker and thought leader. She's followed by over 500,000 tech professionals. Many of you are some of them. I am one of them. And she's been honored as a LinkedIn top voice for the past 5 years and is the #1 artificial intelligence writer on Medium for 7 years. Welcome to the webinar, Cassie. Thank you so much for joining us.
Thank you so much for having me, Brenna. I'm really excited to be here. And about weird things that we do when we're 15, at that time, I actually, honest to goodness, thought that statistics was going to be my easy A because I like numbers. And little did I know, surprise, that it's actually philosophy with some numbers attached to it, which we can get into later. But I'm always fascinated by the range of data professions, all the different styles of thinking, the foundational soft skills that you see in the space. And when outsiders look in, they think it's the everything of data. It's one kind of thing, but it's as different as all the different professions that we do with words. What a lawyer does and what a poet does, two very different professions, and same with data. So I'm pretty excited to dive in, take your questions.
Excellent. I was the opposite. Someone told me to take statistics. I thought it would be too hard, and I deeply regret that because I need it all the time. So just getting started with the questions, can you talk about the role of data and data science in this world of AI?
Oh, absolutely. Actually, I love to frame it the other way around. And okay, this may be a personal bias, but I see AI as part of the data science umbrella rather than data science as part of the AI umbrella. I know, as tempting as it is to subsume something within the latest buzzword, the way I think about the difference between the core data science professions, and these are analytics, statistics, and AI/machine learning. And I use those terms interchangeably because I know I'm a recovering academic. I know that throughout history, there have been different ways that people have used them formally. But at the moment, people just use them interchangeably, and I give up. So now my new favorite definition of the difference between machine learning and AI, if you'll pardon some humor for the afternoon, is if it is written in Python, it's probably machine learning, and if it's written in PowerPoint, it's probably AI. So a little thing there. Anyway, getting back to it. What is the difference between the data professions? So analytics, statistics, and machine learning/AI. People might be tempted to say, oh, the difference between them is maybe the tools that you'll see people using. Or maybe the difference is the math, the algorithms. And the fact of the matter is, if you have enough bloody-minded stubbornness, you can use the same tool for any of them. And you can make an algorithm work for any of them. Whether or not that's a good idea, that's a different thing. But the real core difference, and why I like to frame everything from a decision-first point of view, is the number of decisions that we know that we're making under uncertainty. That is, we can't just look up the answer, then it's a lookup table. It's a whole other thing. But under uncertainty, how do we approach our decision making? So if we have no idea what we want with the data, just like, here's some data, you don't know what's in it, you don't know what you want with it, you don't know what you're hoping to get, what you can hope to do with it is to get inspired. If you don't even know what question you want to ask, it's not the time to be getting answers. You want inspiration. And the discipline of inspiration is the discipline of analytics. And again, you could use many different words here. You could call it knowledge discovery. You could call it exploratory data analysis. The point is, you don't know what you want. And then you need that excellence of the speed of figuring out what might be promising here, but not taking yourself too seriously. And the discipline of analytics, another way you can think of it, is that it is deeply concerned with what is in your current data. You don't know what's there. You're just going to have a look at it and hope it inspires you. It's where you get your best questions. Now, question might not be enough for you. You also want a discipline that will help you get better answers. And that discipline is statistics. So if we look at a little hierarchy, how many decisions do we know we want to make before analytics? None. We have no idea. What if it's a few, one or a few big important decisions? Then you're going to need answers. And you're going to need high quality answers because you don't want to do stupid things in response to your data. Statistics is the discipline of that. And what a lot of people misunderstand about statistics, they think that statistics is about what's in the data. And part of the problem is the name. Because statistics, the discipline, is kind of a misnomer. If you were to think of statistic, the noun, it just means any way of mushing up your data, like taking an average or finding the biggest quantity or the smallest quantity. That's a statistic. Don't become a statistic. Right? But statistics, capital S, the discipline, that is the one that actually doesn't care about what's in the data. It cares about what's not in the data. It says, yeah, this is what you can see. Before your decision, you wish you had more. You wish you had something else. And you need to make a dangerous leap from what you have to what you don't have, to this great unknown. Or if you're taking a 101 class, from the sample to the population. You wish you had the population, you don't have it, so you're going to have to make a leap. Because for your decision, you wish you knew about things that you don't. And the reason that statistics is philosophy is that there is no magic formula here. The only way you can go from what you know to what you don't is by making assumptions. And you personally have to state your assumptions, be comfortable with them. And you take your data plus your assumptions, that's where your conclusion comes from. And if someone else is not willing to make the same assumptions as you, your conclusions do not apply to them. That's also why we shouldn't be using statistics to argue with one another. We should instead say, what would it take to change your mind? Okay, let me see if the data change yours. Mine might be changed, or let me see if yours are changed by the data based on the rules and assumptions that you stated. So statistics is how we play with all these things to make one or a few important decisions ourselves with data. So we've dealt with the no decisions before we begin. Now we want a few big important decisions. What about if we want to make many decisions? In other words, we want to automate. That one is machine learning and AI. That's where it sits under that umbrella. And the fact of the matter is, if you are going to be launching a big, gnarly, at scale AI system that affects a lot of people out there, not just you, then you should approach it responsibly. And part of approaching it responsibly is making sure that when you think it works, that it's actually performant and safe to launch at scale. In other words, the make it work piece, the figure out where the patterns are in the data to automate based on that data, that AI piece, that just gets us to we think it works. Now guess what you need to get to and we can launch it safely? That's statistics again. So you need statistics to do the quality checks for AI development. And what do you need analytics for? If you're going to be automating using data, which is what AI is all about, you may or may not have good data for that process. You might not know what to start cooking with. How good are your ingredients? I love to make this analogy of ingredients to data. So as any star chef will tell you, the quality of your ingredients matters. And if you've just been told there are carrots, just like a label, there's a whole warehouse just labeled carrots, but you don't know what's inside. Maybe they're all rotten. Maybe they're freeze-dried. Maybe they're plastic. You don't know. You're going to have to go in and check, make sure that this is something that you want to try cooking with, because it takes some effort to get that to play nicely with your algorithms. So guess who's good at being the one on rollerblades with a flashlight through this dark warehouse of ingredients, that's your analysts. Everybody is working together, and data science is your discipline of kind of coordinating all this stuff. And I like to think of it as sitting under a bigger umbrella, the decision intelligence umbrella, where decision intelligence is the discipline of turning information into better action at any scale, any setting, which means perhaps with data, if that's appropriate, perhaps the information that you want is going to be petabytes and beyond. Perhaps the information that's more appropriate is some input that you got from a conversation with your mentor at lunch. And that's not in any spreadsheet, it's not in electronic form, but that might be of a lot more higher quality than that warehouse of plastic carrots.
I might have taken that statistics course if the tagline had been the discipline of not doing stupid stuff with your data. That's great.
Exactly. Well, I like to think actually of statistics. Sorry, I was going to say, it's the discipline of changing your mind. That's what it is. What is your mind set to? How does it change? Sorry to interrupt. I just wanted to put that little plug for it's a philosophical discipline. It's a cool discipline. It's still cool. Like I feel like I'm the like shouts at cloud person. It's like, it's still cool, kids.
It's even more cool now. So we know that everyone is clamoring to figure out how AI can help them improve their decision-making process or help with automation. How do businesses know what to automate? And how do they know once they've done that, they're not doing stupid things with their data, that it actually worked?
Beautiful. Okay, so let's go back to basics here. Imagine that you are, first, we've cleared your inbox. You're welcome. And you are teleported to a room. I know. It touches the heartstrings.
It really does.
So you're teleported to a dark room. You are just in the center of it. You have no idea what your options are, what the actions that you can take are. So let's think about what you could do. You could sit and plan out a whole string of things. You could say, let me first see if I can find a window. If outside the window I see rain, then I'm going to sit and stare at a wall and meditate. If I see sunshine, then I'm going to, right, and you make this whole sequence of things you could potentially do. If you are pretty sure that you know how you would structure your decisions and the thing that's missing is information, specific information gathered, then awesome. What you do is you basically lay out your plan for collecting that information. You lay out the sequence of operations that you're going to take, and you take them. In other words, that's the kind of company that says, we know exactly what we want. We know exactly what it would take to make it. We're not sure if we can, but we may as well try, so here's what we're doing, and in this direction. Alternatively, you might be like, well, I've just been teleported into a room. I don't know what planet I'm on. I don't even know if there's atmosphere outside this window. So my first thing that I'm going to do is I'm going to invest in exploring my options. I'm not going to jump to any conclusions. I'm just going to see what I'm dealing with. There's a window. Why don't I look outside first? And then I will start to play with what we could do with this. That is taking an exploratory or analytics approach. So you say, wait, before I'm going to do anything careful, let me have a look. Let me see what my opportunities and options are. Now, there's a little catch there. Is it automatic? Well, think of two people. Let's say you and a complete idiot. You go to the same window. You look outside the same window. You see the same stuff. One of you knows exactly what questions to ask. You can ask them and, can go have a great life. The other one sees the same stuff and it, doesn't land. The skill of the domain knowledge, knowing what you're looking at, knowing when you've been presented with a threat, when you've been presented with an opportunity, and how you might be best positioned to react to this. That is a skill that is not guaranteed by the data. So you're going to need domain expertise. You're going to need leadership. So what I'm really trying to say with this analogy is that when companies think about how they might use AI, first, we can get into why it's the wrong question. How do we use AI? The better question is, how do we make our business better? But what companies need to appreciate here is that they will need to work with all the existing business context, all the goals, objectives that they already have, and the domain expertise that's got that nose for opportunity And they're going to have to put that together with knowing what's possible. And I see such a neglect of all the business stuff. I see a very nerdy excitement that, like, we could identify objects in photographs. Great. What are you going to do with that, though? What do you need as a business? So either exploring your options and coming up with those things wisely, that means starting with analytics, getting to AI later, or bringing in people who have some sense of what you're working with to structure an approach for you, and then go to AI is best. The least good way to do it is to say, we need AI for AI's sake. Where can we shove AI? And I see way too much of that these days.
You, in an article, laid out a set of criteria that I think made this really tangible. Can you take us through that set of criteria, which I think became coined the Kozrykov criteria? Is that correct?
Yeah, that is absolutely. So when people ask me what citizens and leaders need to know about AI, I have a simple answer, and it is the Kozrykov criteria. And here's why. Let me give some background. I'm doing a lot of background giving. I hope you'll bear with me. But if we look at the fundamental difference between AI/machine learning, if you like, and traditional code. To automate a task with traditional code, what you need to do is you need to think to yourself, how should the machine take every step to do the task? So you're basically writing out step by step by step by step instructions. When you use AI for automation, you are using examples, data, to get your wishes granted. When you do the step-by-step traditional instructions, you got to know how to do the task. If you don't know how to do the task, you're stuck. And if the task is so complicated that you can't wrap your head around it, forget it. Which is why traditional programming got stuck. A task that we consider to be simple in AI, like identifying whether a photograph has a cat in it or not, is a really, really difficult task if I tell you, well, you got to write instructions. What do we do with each pixel? Tell me what catness is. That's hard. But it's pretty easy to find 10 million examples of cats and 10 million examples of not cats and shovel that into the system and tell it to find the patterns that are more likely to be prevalent with cats than when the cat's not in the image, right? It's easy because the whole internet is made of cat, as we all know.
Yes.
Right. So, in other words, and I really want people to grasp this, when you program the traditional way, some human being, might not be you, maybe you downloaded a library or something, but some human being was responsible for reviewing every single instruction in there. But when it comes to automating with AI, there are actually only two real instructions. And these are optimize this objective on that data set, go. That's it, just two things. And then there's a third thing. If you think of this in the sense of making a wish to a genie. In the Aladdin stories, the genie just does your wish. And if you picked a bad one, there's a problem. But luckily, in the AI sphere, we have a little safety net. It doesn't automatically just happen and go out there into the world. We have an opportunity to test it, do a little launch test, when the statisticians come in, and check that it is good enough according to some criteria that we set. Mm-hmm. And that right there is the birth, the origin of every AI system. And people think that to understand the most about an AI system, they have to understand how it works. Well, how it works is a broad strokes way. It takes data and finds patterns, but you don't care about that. There's another way you might try to ask how it works. Well, how it works then is try to read the recipe that it's following. And that recipe, it's not that it's a secret, it's that it's long and boring. It's like 10 million stacked pages of boring nonsense. You don't want to read that. And so people get discouraged. How do we trust? How do we understand what we're working with? The answer is, forget all that for a moment. If you know where the system originated from, you already know a lot of things about what you can expect from it. You can see some of the dangerous likely failures. And you can prepare yourself as a leader, as a citizen. So when you remember that the origin of the system is do well on this objective for those data, and here's how we test it. You know what the system is good for in broad strokes. You know a whole lot more than any other approach you could take, including red teaming, which we can talk about later if you're interested. And that's where the Kozar criteria are. The Kozar criteria are that some individuals, some leaders, made some subjective judgment calls on answering those implicit 3 questions. Those are the Kozar criteria. What is the objective? What does success look like? What data set are you going to use? And how will you test it? So objective, data, and testing. If you know about that, you know a lot about what you can expect from the system. So those are the Kozar criteria.
Excellent. Is there a criteria or a shortcut to deciding when you should use general programming versus AI as a solution?
Absolutely. So there are 2 ways to think of this. First is AI should always be an act of desperation. Now, let me explain myself. If you were to program a human to do a task, and you had the option between explicit instructions that you had full guarantee that the human will follow every single time. So don't worry about machines for now. Just imagine this as humans. So either you can write explicit instructions and the human will do exactly what you need, or you can say, here, watch me do it a few times, and you figure it out. Why would you want to do one versus the other with a human? So what's great about explicit instructions? Any control freaks among us? That's where you get control, right? That's control. So you are guaranteed that you know exactly what they're going to do. They're not interpreting anything. You don't have to worry about them seeing some other pattern than the pattern you hoped for. Right? Like maybe every time it's a full moon, you want a cappuccino and the rest of the time you want a latte. But the few times that they saw you making orders, it was also raining outside when you ordered a cappuccino. It was sunny when it was a latte. They won't understand it has anything to do with the phases of the moon. They're going to come to the wrong conclusion, and one day it's going to be a full moon and not raining, and they're going to make a mistake. But if you tell them, check the phase of the moon, then order my drink, it'll work every time. So you always prefer the control if you can have it. And that is why AI is so exciting, because it is really, really hard to come up with instructions for some tasks. In other words, human minds have thought about it, been like, how do we write down this special formula for catness so that we can take all the pixels in a photo and turn it into a cat? And they've been like, no, this is too hard. Some cats have flat ears and other cats are liquid. This is hard, we can't do it. And so then the only way left to them was there was a whole lot of examples. Maybe there's some fruitful patterns in them. Let's have a try and see how well it does. So any task that you can automate the old way, please, for goodness sake, you like control. Control is good. Control is robust. Control is resilient. Control is reliable. But for so many tasks where you have nuance, where you have complexity, where that model, that recipe is just a fancy word for model. Yeah, other way around. Model is just a fancy word for recipe, where you have a really, really complex recipe. In other words, a problem with a complicated solution. You can't solve it with a simple solution. You can't solve it with something that fits in a human's head. You need much better memory, and computers have much better memory than humans. As proof of this, I need only show you 30 numbers, remove them from the screen, and ask you what was the 7th number. You've forgotten. But a computer remembers. Oh, you can flip back to the, I like to do this in slides, you can flip back to the previous slide. Look at that, thanks computer for remembering. So when you want to have these really, really unwieldy, complicated recipes, that's when you want to try with AI. There's no guarantee that AI is going to work. But whenever it is easier to make the data, to make the examples, than to explain how a task is done, and when you have the examples and they're of high quality, you got a lot of them, then try AI. So that's the sort of bigger, more intellectual answer. The much simpler answer is there are classes of tasks where researchers have for years been trying to do it the old way, and they couldn't succeed. And if they're only succeeding now with AI, well, that's your hunch that, maybe if you have a similar task, try AI. Like, I was talking about finding cats in photographs, and you need to find dogs in photographs. I feel like it transfers a little, right? So you might want to try the same approach if you're trying to find objects in images.
Great. We have a poll for everyone that's joined us today, and it is not what degree of control freak you are. It is about the adoption of AI. You can answer on behalf of your team, your organization, or yourself, but we're just curious to see where everybody is on their AI journey. So that'll be up on the screen for just a moment. We can't have an AI webinar without talking about the concern that everyone has for the impending future of what will come. One of the questions is, whose job is getting automated? Can you talk a little bit about what you've seen in your experience and the conversations that you've had?
Happy to. And I'll preface this by just declaring my camp, my affiliation. I am in the realistic, pragmatic optimist camp. So it's flavored like, the world's not going to burn. I find those views on the ridiculous side. On the other hand, I see this a little bit like, have you ever seen car seatbelts in the 1950s? Like baby car seats. Right. So anyone who hasn't, it's hilarious. Go have a look. And then you'll realize, well, things are better today. I imagine there were some growing pains, right? That might have been, even tragic. And I'm really glad that we're here today. I'm glad we're not there anymore. And in a similar way, we may have some growing pains, and I would love for the equivalent of seatbelt advocates to, encourage the world to not have to learn the hard way. But just as with cars, look at us having a lot of cars, getting things done, and it's not like the world has ended. So, wait, I've gone all into that deep end. What was the question again? The specific one. The jobs, yes. So the jobs. Every decade, there is this, people are saying robots are going to take all our jobs. In the 50s, you've had it in the 70s, like you've got all these ridiculous articles that we got to go back and laugh at ourselves. I feel like we're working more, not less, and the economists seem to agree with me. But if we're going to be absolutely technical, whose job does AI automate? Not in terms of downstream economic effects, but AI itself. Technically speaking, it's about programming. It's automating the programmer's job. But I've already told you, if you can code it the traditional way, and you're not stupid, you should do it the traditional way. So AI unlocks all the stuff that we could not automate the traditional way. So programmers are safe. This is opening automations that we thought weren't on the table because no one was clever enough to come up with the recipe. But now we're clever enough to collect all that data, find the patterns in it, and create automations based on that data. So all of a sudden, it's a quantum leap in human progress. Tasks are on the table for automation that just weren't on the table before. So AI itself, in some sense, nobody's job. But in a much greater sense, what happens to a world when, for the longest time, we thought that it was not possible to automate certain things? And now, like a wrecking ball through the economy, we're going to question all of it. Things that we thought were always going to be human only now get a little assistance from machines. So what are the types of tasks that are on the table? Pretty much everything that we do that's repetitive and digitized. Like if humankind has a lot of this and is all very similar to itself and it's digitized, that's your top target. And maybe the roughest, cruelest way to put it is the more copy-paste you experience on a day-to-day basis, the less safe your job is.
Good to think about that. And I appreciate your pragmatic, realistic, optimistic view. It's nice to hear those. Our poll results are in, and it looks like most people answered that they're somewhere in the middle of their journey, starting to explore, currently implementing. The 2.9% that are fully integrated, I bet we have questions. You should reach out to us so that we can ask you some things.
Yeah, and I'll say the ones that aren't considering it, AI is there already, right? Like it's really, really hard to have a modern company, particularly if you guys are using your computers to dial into this webinar. There's some AI is going on, just saying. Some of it's already touching you. So I'm not sure if that's a category that's true, right? No, it's somewhere there, very likely.
Lurking beneath the surface?
Lurking, yeah.
So you have written a lot about AI literacy for all. So what types of AI skills should all of us either have or start adopting very quickly?
Okay, I have a list. And such a long list, I'm going to have to try my best because I'm not sure I'll remember all of it. But first, obviously, the bias exists, so we're just going to lead with the bias. Decision skills. How I think about a lot of our progress with data has been, Brenda, when you were in school, did they make you write out letters, like learn how to write with cursive? And you just like wrote a lot of A's, right? Over and over and over? Yes. Yeah. And that is not poetry, but you were learning how to be able to do some of the things that would eventually allow you to write an email or a poem.
Yes.
So a lot of what we've done as a species with data has kind of been like that. Let's just make it so that we can write an A. Let's just make it so that we can write a B. Let's just make it so that we can make a word, like the equivalent of that. And now all of a sudden we'll start graduating into, what should we write? And we'll find ourselves dealing with situations that don't have one single correct answer. So it's fairly straightforward when you have a template and an A always has to look like this, and we could just check, did we get the A or didn't we? Now, whoa, what does right look like? Could be anything. You tell me what's important to you. And when we start thinking like that, we are thinking about decisions, values, priorities. And we have to shape what the world needs to mean to us for us to act one way or another way. And all this data stuff then it's just tools to assist us in our journey. And so those are core skills, fundamental skills. And actually on this topic, most of my list is going to be soft skills. And I don't like the term soft skills. I prefer to call soft skills skills that are hardest to automate. And the more something is boring and has one right answer, the more automatable it is. Like that's your perfect target. Arithmetic, perfect. Calculus, perfect. One right answer, pretty boring. Now, graduate level mathematics that takes creativity, difficult to automate. Actually connecting with the artistic conversation that humanity is having with itself for millennia and making a statement that grabs the hearts and minds, the true act of the artist, hard to automate. Outputting 10,000 potential drafts to ask the human artist which one they like best, easy to automate. And so the soft skills, that nuance, decision-making, design, those things are hardest to automate. And then social skills. There is no substitute for true human contact. That's going to be very, very important in the future. I think we'll be spending more time, and luckily we're kind of designed for this. So that plays to our strengths as humans for most of us to interact more with one another rather than be a copy-paster in a cubicle in the dark somewhere. And then, of course, the two big ones and the scary ones are trust and collaboration. They go hand in hand. Because as our systems become more and more complex, we're not going to be able to do the whole thing ourselves, right? Like, imagine if in order to hear me speak, all of you listening would have to have built your own cameras and your own computers and your own cables to connect to the internet. Like, you wouldn't be able to do that. You have to rely on other people to handle some of the process. And as you get more and more complexity, you're going to have less and less insight into the other pieces. You're going to have to work more on the boundaries between where your work begins to end and your collaborators' work begins. So how do you think about working on those boundaries? How do you compose teams of humans who are working on very different things, but they don't fully understand one another's role? And when the tools become more complicated, how do you figure all that out? Things are complicated already. They're going to get more complicated as our technology becomes more sophisticated, more nuanced, more personalized. And then, of course, the trust piece is huge. And the trust piece is not just how do we pick with whom to collaborate, part of that collaboration skill, but also how do we adapt our habits of gullibility? How do we screen what's likely to be information that serves us versus information that doesn't serve us? The quick guiding principle of trust, competence plus incentives. It's hard. It's going to be harder to evaluate both the competence because you won't understand that whatever that person or system does, and the incentives. So trust is going to become an interesting game. And as people hone their trust skills, they're going to have a real advantage in the future.
So many of these skills, and I love that they're skills that are hard to automate, they're unique to humans. And now that us humans need to continue to befriend the machines, work with AI, it seems evident that we need to adopt lifelong learning and constantly be evolving and growing new skills faster than we've ever had to be before. So what is your advice to companies to create a culture where they're both hiring for these skills, but also developing over the tenure of the employee's life cycle?
Oh, I have so many things to say to companies. Goodness. And thank you for calling out the change management skills, the adaptability skills. Those are also huge ones. Being a lifelong learner and having a self-identity where you don't rest on your laurels, but you are open-minded to future things. That's a great future-proof update. But let's talk to companies. There is a long history in managing what we can measure. And if you think about this, there is something that should make you really uncomfortable. Because when we measure all kinds of things that we manage, where do those measurements go recently? They get digitized repetitively. In other words, the things that companies are best positioned to manage is the most automatable stuff. Mm-hmm. And so I've coined a new word to help with this. So there's thinking, you all know what thinking is. And then there's another one, I call it thunking. And that's like thunk, 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 like the sound of a dull brick thudding. And we all know, no matter what our job is, no matter how fancy it sounds, astrophysics professor or whatever you like, there is some amount of your job that you know it, be honest in your heart, is thunking. And sometimes it's even relaxing. You settle down with a nice cup of coffee for a good thunk. For me, I find it extremely relaxing to do data entry. I shouldn't be doing data entry. I should have grown out of it long ago, but I found this as a little personal pleasure at age 8. And I like to do a little thunk, enter some data, sort my little spreadsheets. Very nice. But I know that during that
time.
What's that?
When I play in Excel, that's my adult coloring book time. It just
exactly. So thunking, it's beautiful. Thunking is the adult coloring book time. Exactly. And we all know that it's so nice and calming. And we could be playing Candy Crush or 2048 or whatever else floats your boat. Solitaire, Free Cell. I know a lot of you feel me calling out your drugs. Yeah. And so, right. People feel insane. A lot of what we do during the workday has these thunking periods in it, and they're nice and they feel good. But that is so, because it's so repetitive and digitized, that is so automatable. And we used to enjoy this weird deal with our employers, where we would get measured for the thunks, we would get occasionally praised for the thinks, and the relationship between the two of them would be tenuous. Now, imagine what happens to a world when all the thunking is automated. And that was the only bit that anyone knew how to manage. What do we do now? What if you can create a brilliant insight once a week that changes the whole course of your company? Sounds good, but what kind of manager is going to have the guts to let you play solitaire and have a brilliant insight? It's very uncomfortable when your butt's not in the seat for 9 hours a day. We had to have that growing pain during the pandemic. It's very uncomfortable when we can't say, hey, look at this work product that I definitely made because I toiled. We don't know how to manage past that. So I wish I could offer a solution, but what I really want to say is I want to see business schools working on this. I want to see more research into creativity. Because there will be debates of, maybe, and the stupidest thing that people will say is, well, now that we've thrown out all this thunking stuff, can't we just get the worker to do 9 hours of thinking per day? And that sounds ridiculous to any psychologist around. And that's kind of like, if you're having your best ideas when you go for a walk, maybe, and the walk is the bit that you can measure, that you can manage, and then you have some manager yelling at you, walk faster, so we can get more measurable improvement work product. So you start walking faster. Maybe you even get better ideas with breaking a little sweat. But if pushed to its logical conclusion, you are made to sprint the entire time. My guess is no good idea is going to come out of that. So it's a delicate balance. We have no idea what to do with it. But I do warn companies that they are addicted to managing thunking, to managing the repetitive and digitized. And that is exactly what is most automatable. But that was never what was best about their employees. That was what was best about their job as managers. It was easy to manage something. It's going to be very hard to manage things in the future. But the best of us as humans it was never the thunking. It was the social interaction when we're on, when we're not like checked out and saying the same thing to everybody, but when we're having a real interaction, when we're doing true creative problem solving, when we're brainstorming with one another, when we're having ideas. That is when we show the best of us.
Absolutely. I love that. I'm going to embrace my thunking time, my dog walks, all the things that spark creativity and great ideas. I know there's a lot of questions coming in from our audience. I have one question, which is never a fair question. It's what we always do. We take a super smart, experienced person and we say, you must have a crystal ball. What do you think AI is going to do to the tech industry over the next decade or so?
So I love this one because I like a bit of self-referential humor. Because my answer is going to be hilariously self-contradicted. I hate an unnuanced answer where the answer itself is nuance. Boom. The future is nuance. Personalization, but not just personalization. It is the shattering of categories. If you think, for example, about medicine, and we think about, let's take gout. How many kinds of gout are we thinking about? Is it one disease or is it 500,000 diseases? Or if you look at the Diagnostic Statistical Manual for Mental Health, how many mental health conditions are in there? Just a few. Whereas maybe each one should be sharded into millions of different categories. But how could you have a human medical professional think in those terms? That's too much, doesn't fit in your head. You want it simple. Gout, no gout. Depression, no depression. But as we have machines helping us with that memory, and as we have a lot more data and complex, sophisticated data sets coming in, we can now suddenly handle more nuance. And yes, when we talk to one another, sometimes our tweet-weaned attention span comes back into play, and we're just like, tell me the middle thing, give me the tweet-length answer.
Yes.
But our systems will now be able to handle much more nuanced categories. So this is beyond personalization. Everyone's talking about personalization. They're saying things like, why should you play the video game everyone else is playing? Why can't we have a video game that is customized, personalized to you? Instead of Solitaire or Free Cell 2048 or Candy Crush, the perfect game for each individual. Nuance is more than that. It's not just your individual thing, it's all the possibilities, all the spaces between categories can now be represented. And we've struggled in our journey into broadening our categories, but we will, with the way technology is going in the future, be able to actually sustain that kind of psychological growth of our species, if you will, across so many more things. I'm really excited for that. And that's going to create a lot more work. When you jump from anything binary to non-binary over many categories, whoa, there's so much you're going to have to do with that. So whenever people are thinking of a future where we've got nothing to do, even aside from all the big problems we haven't solved, all the medicines we haven't discovered, all the inefficiency, climate change, and you name it, all the art we haven't made yet, all the solutions we haven't invented, even aside from all that, just looking at the types of things that we're working with right now and charting those categories, there's going to be so much to do. So I'm pretty excited for that. So nuance is my answer.
I love that answer, and I am excited for that too. It's a uplifting note to transition now to a Q&A from our audience. So let's get to, there's quite a few questions. I'm going to start to go through these. Before I do, Chelsea will wrap up for us, but I want everyone to know that we do have a special offer that we're going to email you afterwards if you are curious to get started either hiring for AI talent or learning more for yourself or your teams. Let's see. All right, Lad, this one came in kind of early. What is Gen AI? How useful is it?
Okay, Gen AI. So here's how to think about people call it traditional classical AI. Its real name is discriminative or predictive AI. That, in a nutshell, is the kind of AI where there is a right answer, one right answer. So, show you a photograph, you tell me that's a cat or that's not a cat, there's a right answer there. And then you have another kind of problem, where I say to you, go photograph a cat for me. Bring me back this photograph. Now you go out into the world with your camera. And if you go downstairs just in my building, you will see about 10 cats on your way to the grocery store. So you ask yourself, well, Cassie wanted a cat, but I could send her a photo of this cat or that cat or that cat or that other cat. And they're all the right answer, all of them. There is no one right answer. They're all good. And they all suit the purpose. These are two very different kinds of tasks. So the kind of task with one right answer, that's your traditional, classical, discriminative, predictive, pick your label that you want. It's about labeling, so I tell you, label it, you label it, go ahead. AI. Generative AI is when we are generating possible right answers to a prompt. I asked you for a photograph of a cat, go knock yourself out, bring me back any suitable, it's still a cat kind of photograph. And when we think about these systems, right, you can see that there is a lot of potential, particularly with art, that instead of having to go out, well, maybe I need to illustrate my slides, I need a cat for that. And I'm like, I don't have time to go take a photo, you go do it. Obviously, it'll save me a lot of time. But when I start to, in business, say, okay, but not every okay-ish answer is going to be as good as any other answer. Now, I, as the business leader, have to start making statements about what does good look like, actually? And before you go out and take that photo, I'm going to have the mental wherewithal to make some standards and to foresee the types of options that you could bring back to me while still meeting my prompt. And so in order to test your goodness, I'm going to have to start having a very big brain. Or I better not make you do anything important and I'll just see what you give me. That's the generative AI dilemma right now. It's very, very hard to use it for mission critical things because dealing with managing something that gives a lot of potentially right answers is hard. Mm-hmm. Much harder than the traditional kind. But it also really expands the type of stuff we can automate. Hey, make me a song, any song. Get me a cat, any cat. Make me a poem in the style of Shakespeare about bananas. There's no one right answer there. Yeah.
Right. All right, we have another good topic. So can you guide or give pointers for AI in ethical decision making?
Okay, now let's talk about a broad area. Right. So I was feeling like someone call an ethics professor, please. This is not my kind of philosophy, and should be handled with, we should have the wisdom to ask the wise among us about this. But again, let's start from first principles and say, if we are automating, what is one of the biggest ethical considerations? It's that AI fundamentally has the same promise and the same peril. Same thing in both cases. And that is, it is very easy to be thoughtless. It's a thoughtlessness enabler. Now, this is great. It's very promising if you are automating a task that, for example, only affects you. And if you, singe your own eyebrows, it's fine. So being thoughtless when it's just about you and you, it's fine. Or if it's fundamentally not mission critical and you're just like making pictures of cats, also no big deal. But what if it is something mission critical that affects other people? Well, then this lovely thoughtlessness enabler where you could just be like, here's my objective, here's my data set, okay, go automate it. That, just fun when it's just you, can be very unfun when it affects thousands, millions, billions of other people. And now that we are able to amplify that thoughtlessness, we get all the potential ethical problems of negligence at scale. Should we allow individuals without decision skills, without knowing what they're asking for, to go and automate something on behalf of billions out there, and then have it be a garbage fire? ethical questions. Should you, if you know that you are not qualified to think through the consequences of what you're asking for, should you then automate at scale? Ethical question as well. But I hear all kinds of ethical takes, and I've seen this in Forbes. In 2022, there was a list that came out of top ethical questions in AI. And I saw one, a very similar one from the World Economic Forum a few years back. And what I go do is I just take those questions and I replace AI with technology. And all of it still fits, right? How should we approach the income disparity effects of technology? How should we make sure that technology doesn't have terrible consequences? How should we make sure that technology doesn't fall into the wrong hands? How should we make sure that technology brings prosperity and not badness to our society? Those kinds of things. Still works with technology. I'm glad that AI is bringing attention to ethics of technology questions, but they're not about AI. We should be talking about these things, but we should be talking about them in the sense of technology in general and answering them. Right? Who gets the benefits? Who gets the wealth? Should we concentrate wealth from technology? The part that is AI specific, that is the thoughtlessness at scale. The way that we make it really, really easy to go, here's my objective. I didn't think about it much, but here it is. Optimize on that data set. I didn't even look at what's inside the data. I didn't worry about where it came from. I didn't worry about any biases in it. Okay, just make that be the blueprint for my large-scale automation. What could possibly go wrong? So understanding that we're dealing with a thoughtlessness enabler means that ethically maybe our reaction should be to insist on more thoughtfulness back into the Kozr criteria. More thoughtfulness about what success should mean, what it looks like, what's good, what's bad, and how do we score them. Think of a simple AI system. It detects cancer. Simple. There are 4 things that could happen. It correctly determines, let's say it's brain tumor, and we're seeing if it's a brain tumor has been detected, we're seeing if it's benign or malignant. 4 possibilities. You say it's benign, you're correct about it. You say it's malignant, you're correct about it. You say it's benign, but it's actually malignant. You say it's malignant, but it's actually benign. Those 2 mistakes. How much worse is one than the other, please, decision maker? There's not one right answer here, ethically. If you say one of them is a lot worse than the other, you're going to do the other one a lot. That's going to be your dominant mistake. So maybe you'll tell a lot of people that their benign tumors are malignant. Does that scare you? Maybe you'll skew the opposite way. Or you'll treat them as equal, but are they equal? Very deep, problematic ethical conundrum that I really hope some leader is thinking hard about. I don't want to hear that some nerd just came in there and was like, F1 score, that's our metric, off we go. Take the problem more seriously than that if it is a more serious problem. So put that thoughtfulness back in. Think about what you're doing.
I like that you brought it back to the Kozr criteria, because I think one of the things that when we approach AI is it's almost auto magic, but you have to spend just as much time making sure that it's working and it's working without harm as all of the other ones.
Exactly. And you can't start there. You can't start with making sure it's working. That's the problem. Right. That's a very engineering-y mindset, and a lot of engineers have it. Yeah. Where you got to start is, what are we trying to do in the first place? What would make the world better? What would make it worse? What's our objective here? And then work back from that. Not, we inherited some alien technology. Is it working? Working, here's the statistician in me again, right? This is philosophy. What does it mean to work? That's up to you, but you got to specify it very carefully. You got to start with that. Everything else comes next.
We have time. There's so many questions, and we'll do our best to follow up with these, but we've got time for one more. So I'm going to ask, what skills do leaders need to grow today to be able to lead in times of accelerated technology innovation and adoption?
Brenna, is this a real question from the audience, or did you throw me this one? Because you know what I'm going to say here. I'm going to say, thank you for finding me, person who asked this question. This is what I'm all about. This is exactly why I'm trying to teach people the skills for the front bits. How do we set up the decision? How do we think about what we're doing? How do we think about what's worth doing? And how do we then connect that down to technology? Decision intelligence, the discipline of turning information, better action, any scale, any setting. How do we figure out what we're trying to do and make sure that we're doing it right? Whether or not we go and use enormous data sets or we don't. That's the skill that leaders need. And then, of course, the skills I mentioned before, trust and collaboration are going to be super scary. And you also need that change management, adaptability. Those are the skills that you're looking for. But remember, these systems, all that thoughtfulness that's required, they don't teach that in nerd school. That is about what is right for your business, what is right for your world, what is right for the people that it will touch.
Excellent. We are on that hour just flew by. This has been so fun. I've learned so much. Cassie, thank you for all your expertise and your insight and your humor. Thank you for making it so fun and approachable.
Thank you for having me. I really enjoyed being part of it.
Yeah, thank you both to Brenna and Cassie for such an engaging discussion. So what's next? We will be sending out a webinar recording to everyone that registered. So everyone on this call, in the coming days, you will be getting a link to view the recording at your leisure on demand. Like Brenna said, we got a ton of great questions today. We weren't able to get to all of them, which is a good problem to have. So we will try to follow up personally with everyone that we were not able to address. And if you have any questions, comments, concerns, or you want to reach out to me directly, I have my personal email address on the screen, so feel free to reach out at any time. And lastly, as we wrap up, I'd like to encourage all of you to explore the CodeSignal Skills platform and see how it can help you go beyond skills gaps with hiring and AI-powered learning tools. You'll see two links up here on the screen. If you're an individual looking to build your tech skills, you can visit this link here, codesignal.com/learn. And to learn more about our teams and enterprise solutions, you can visit this link, codesignal.com/products. But like I said, feel free to email me directly and I'm happy to route you into the right direction. So again, thank you to our speakers, to Cassie and to Brenna for your time and your insights and your expertise. And a big thank you to everyone joining us today. So thanks everyone for attending. This concludes today's webinar. Have a great rest of your day.
Thank you.
Thank you.